Today, we're going to learn a new way to find the derivative. This is just a new limit. In class, we'll see why this limit today is the same as the limit that we computed last time, or that they're equivalent ways of computing the same thing. So first of all, we remember that the derivative gave us the slope of a tangent line at a point. And last time we had this definition of the derivative, that f prime of a was the limit as x approaches a of f of x minus f of a over x minus a. And we had said that this piece was like the slope of a secant line. So we were looking at limits of slopes of secant lines, which gave us a slope of a tangent line. Today we have this new definition. We have h approaching 0 of f of a plus h minus f of a over h. We notice that the f of a is the same, but the other pieces have changed a little bit. So that's kind of interesting. So what we're going to do in this video is we will just do computation. We'll just compute the derivative using each of these limits. In class, we will see why these limits are the same and why the second one also gives us the slope of a tangent line. So let's just jump right on in. So we're going to practice using both derivatives, make sure that they should give us the same answer, or both definitions to get the same answer. So for example 1, we're going to use f of x is x squared and f prime of 1. So let's use the first one. We should be familiar with this one, so go ahead and practice. So f prime of 1 could be the limit as x approaches 1 of f of x minus f of 1 over x minus 1. We notice here that f of 1 is just 1 squared, which is 1. Okay, so we're going to have x squared is f of x minus 1 is f of 1 over x minus 1. I forgot my limit there, guys. You should be calling me out on that right now. So this is still a limit as x approaches 1. Now, if we plug 1 in, we get 0 over 0, so we have to simplify that. We can factor the numerator as x minus 1 times x plus 1. And we have an x minus 1 in the denominator, so the x minus 1's cancel out. Then when I plug 1 in, I get 1 plus 1, which is 2. Okay, so now let's use that. That should have just been review. Let's use the other definition, our new one. So f prime of 1, according to this definition, should be a limit as h approaches 0. H is always approaching 0 in this definition. F of 1 plus h minus f of 1 all over h. Okay, so let me go ahead and plug. We know f of 1 is 1, so we're going to have a minus 1 at the end here. This piece is the one that students often struggle with. So all we're doing is we are replacing the x in our function with 1 plus h. That whole 1 plus h replaces the x. So if I look at f of 1 plus h in this case, we replace that whole x. Everywhere we see an x, we replace it with a 1 plus h. So we have 1 plus h squared here. Okay. So now we have to compute this limit. I think a good idea here would be going ahead and squaring 1 plus h. So we're going to have 1 plus 2h plus h squared minus 1. That would be what you get when you multiply 1 plus h times 1 plus h, which is 1 plus h squared. Okay, so now the 1's cancel out. I can factor an h out in the numerator. On the test, several of you made a mistake about not factoring that h out. So make sure you factor that h out. You can't just cancel one of these h's out because of the addition. We can cancel this h out now because that h is being multiplied by the 2 plus h. And now if we plug in 0, we get 2 out. So it's a good thing. We found that both of these definitions agree. The derivative at 1 is 2. That's the slope of our tangent line at the point when x is 1. Okay, so let's do, this problem tells me to use our new definition to find the derivative, to compute the slope of the tangent line here. So what we're looking for is f prime of 4, because that's the slope of our tangent line. They wanted us to use the limit as h approaches 0. So this will be f of 4 plus h minus f of 4 all over h. So to find f of 4 plus h, I'm replacing the x in my function with 4 plus h. That is all going to be under the square root. When I plug 4 into square root of x, I get 2 out. It's all over h. To compute this limit, I have to multiply by the conjugate. So I'm going to multiply by root 4 plus h plus 2 over root 4 plus h plus 2. So I get a limit as h approaches 0. When I multiply that numerator out, I'm going to get 4 plus h. And then when I multiply these two, I get minus 4 all over h times root 4 plus h plus 2. The 4's cancel out. They subtract out. So I'm left with h over h times root 4 plus h plus 2. Cancel the h's out, so I have a 1 in my numerator. And when I plug in 0 for h, I get 1 over root 4 plus 2, which is 1 over 2 plus 2, which is 1/4. So that is the slope of our tangent line at that point, or the derivative at the point 4. Okay, and let's do one more here. Try this one on your own before you watch me do it. So once again, we're going to be looking for f prime of -1. This problem does not specify which limit it wants you to use, so you could technically use either, but let's get practice with the one that we're learning today. So let's look at the limit as h approaches 0. F of a in this case is -1, so we're going to have -1 plus h minus f of -1. All over h. So limit as h approaches 0. F of -1 plus h means that everywhere I see an x, I have to replace the x with -1 plus h. So I'm going to have 4 times -1 plus h quantity squared. I'm replacing that x. And then I have this x as well to replace with a -1 plus h. Okay, if you're struggling with that part, computing the f of a plus h, you should ask me, because if you can't do that part, you're going to be stuck for the rest of the problem. So just ask me about that. So now when I plug -1 into this function, f of -1 is going to give me 4 minus 1, which is +3. So -3 here, all over h. Okay, this looks messy. So I'm going to multiply this guy out like I did in the first problem. So I'm going to have a limit as h approaches 0, 4 times. I'm going to have 1 minus 2h plus h squared. If you need to go ahead and multiply that out in pieces, do that. Then I'm going to get rid of the parentheses because this is all plus. So I'm going to have plus -1 plus h minus 3 all over h. Distribute this 4 here. So I'm going to have a limit as h approaches 0 of 4 minus 8h plus 4h squared. I noticed that this, ooh, goodness, sorry. The -1 and the 3 over here combine to give me a -4, and then I still have my plus h all over h. So the -4's cancel each other out. Everything else has an h in it, so I can factor an h out of the numerator, which is good. I need to get to a point where I can do that. So I'm going to have -8 plus 4h plus 1. You could have combined that -8h and the 1 before you factored out the 4. Or factored out the h, that's okay. The h's cancel out. When I plug 0 in, I get -8 plus 1, which is -7. So that is the slope of our tangent line at that point.